Hello YouTube. Here I decided to dig out my Victoreen 700 Geiger counter. As you can see, has the depleted uranium check source. I got it for free probably about 10 years ago, and I've used it on occasion for checking, not accurately, but just to see approximately how radioactive things are, like uranium marbles and stuff. You've seen in some of my other videos, I bring a calibrated meter home from work for actually accurate measurements. But this thing's just kind of this cool piece of Cold War era technology that unfortunately this morning I went to test a Fiestaware plate from 1937 that I got from a friend. And I go to turn this guy on here, and all I get is, oh, well, oh, there we go. You guys can see it. You probably can't really hear the buzz in the video, but basically it just goes full scale when I put it on 10x or 1x. And there's a, we'll hold it up to the camera here. There's a audible buzz. So clearly something has failed in the electronics. My guess is based on the buzz that's going to be in the high voltage power supply. I don't know a ton about the circuitry on the inside of these, but I did do a little bit of research before starting this video. They're really trivial. They operate on approximately 900 volts DC, and they use a very old style switch mode step-up converter to do that. So I'm going to take the batteries out and take this plate, this PCB out of here, and we can take some measurements and see how that looks. A tip for anyone that has these, I don't have it on the table here with me, but what I actually did is cut some painter's plastic. So when I'm storing this, I just put a piece of painter's plastic on here, push the batteries on top of it, and then it keeps them from being shorted out. It keeps corrosion. You can see I've repaired that corrosion before. It leaves it so I can keep the batteries in it on the shelf, you know, a year at a time between use and not have to worry about it degrading anything. I've never taken this apart before. These screws are pretty old. So we'll see how easily this comes out of here. Okay, first thing I noticed, the leads are very stiff. It's solid core wiring, so we probably want to be careful there. I'm just kind of examining some of these leads here to see if there's any shorting to the board. I don't see anything now that would point to that, or any bad solder or corrosion over time here. Everything looks okay. So here we go. We can kind of see where we're at. We took these two bottom plates off. Now, this board looks like it should just, oh, you know what? We are still being held in by the dial on top, so I'm going to grab a small screwdriver here. We'll pull that guy out. Oh boy. Gonna have to get some leverage on this guy. There we go. Probably hasn't been loosened since it's taken off. Huh. Made in Chicago. Look at that. Back when we made plastic things in America. And interestingly enough, it's still very snug. Not sure if... There we go. Okay. Yep. I just kind of pushed down on that center rod there. Trying to see, we don't have a lot of space on the headphone jack. I think that's going to be next. problem we run into here. I'm pretty sure this comes out, yeah, this comes out the top. So I could unsolder the headphone jack and see where we get to. Oh, also this grounding cable here, this is actually what our limiting factor is. So I'm just going to loosen this guy up if I can. Ooh. That is a tight angle to do here. All right. I just want to get this thing out enough to flip it over. I don't want to have to unsolder all this stuff, but it's starting to look like I might have to. At least this speaker jack. I'm assuming that this is some sort of compression fitting. I'm not sure. Let's just see if it lightly will turn here. Yep, okay. Actually, it turns very easily. I want to see if I can just pull some of this Geiger tube line out. Yeah, if loosen. Ooh. Nope, that's just fun. Okay. Probably should be doing this over newspaper or something, because my guess is this is, well, I mean, hell, everything had lead in it back then, but probably leaded steel case. The paint's definitely going to be lead enamel. Obviously lead solder, although I still use lead solder pretty often anyway, so. Huh. Interestingly enough, this really does not want to pull through there at all. Yeah, it seems to be fit on there pretty well. So I think the next thing I'm going to do is we're going to loosen up this gauge here. Kind of taking the same approach. Pop these off. Once the circuit board's out, I will try and retighten them maybe if we can. I know all these mechanics watching this video are probably loving my use of a wrench there, but they're pretty much finger tight, so I think we're okay. Okay, we're going to take this guy out. When I was reading, I was told this is a 50 milliamp full swing dial. So there's some information in case you guys didn't know. Alright, so here, one of the instruments that people commented are prone to failure is this little guy right here. It's essentially a voltage control device that works similar to like a Zener diode, but it actually uses radium paint inside of that, I believe. It's radium to cause a spark gap to happen earlier. So this will spark at about 300 volts. Apparently, the half-life of that radioactive isotope, that was only 22 years. So since these units are, you know, at this point, somewhere around getting close to 50 years old, more, you know, give or take 10 years, I'm not sure when this one was manufactured, quite a bit of that radioactive isotope responsible for helping the device arc has worn away, or, well, disintegrated into other elements. The other detail, I'm not sure what this electrolytic capacitor here is for. It's only 3 volts, so even if that's starting to fail, I doubt that's the problem. I think that would just short the power supply. I see some small diodes here, but again, those are probably film diodes. So my guess is those are okay. These devices pretty much use all germanium transistors. There'd be one guy right there. There's a second one right there. Possible that those failed, but since we're still getting a buzz, I have to believe the device is still switching, which then starts pointing to this transformer device. I don't know what type of power supply this uses. My guess is some sort of early flyback or just unregulated resonant transformer that's relying on a spark gap of some sort to limit that voltage. So the other item that I'm not sure what it is this 700 154. It almost sounds like, from the limited reading I did, this might actually be a custom either circuit or box of some sort. Let's see if we can see how many leads are on the back of that guy. Looks like 6. So it's some sort of custom circuit by the sound of it. That is what's responsible maybe for actually doing the counting and filtering. I'm going to see if I can... I can't really bend that guy up. But there's this other black device down here. I'm not sure what that is. It does have a positive marking on it. My assumption there is that's some kind of... It's my multimeter. Some kind of diode. Possibly another high voltage diode used in that switching supply, so we can test that guy as well. But my assumption is it's one of these 3 components. If it's the transformer, we're probably SOL. If it's this spark gap regulator, you can basically stack some Zener diodes together to have a breakdown voltage of about 900 and replace it. So that's good. I mean, you kind of lose this interesting historic device, but at the same time, since it's based on a radioactive element that's constantly decaying, it just will not last forever. Even if the device was never turned on in the last 70 years, this is going to wear out. And third is whatever this is. If that really is a diode, then that's replaceable with any modern diode. Since you are working with 900 volts, just be, comfortable with electronics and some, methods of measuring high voltage. Obviously, don't have this sitting on anything metallic or conductive. Don't keep both of your hands on the circuit board at any time. That's a great way to get electrocuted. The good news is it's a very, very low current source, supposedly. So I'm guessing if you did get electrocuted, it would probably be something similar to the old-fashioned film cameras that have like 400 volt flash circuits, the small disposable ones. They're probably not enough to kill you. My guess would be not even close. But you don't really want to try that out. So I think to do this, I'm going to have to put the batteries back in just because I'm not familiar, but essentially one set of this powers one part of the circuit, the other set of batteries powers another set. So I'm not sure if I can just plug this into a 6-volt power supply and have it still continue to work. I'm going to use a real professional here. We're going to use a bag just to help put a layer of insulation between my battery compartments here, so that none of the wires are shorting out. And I don't think... just trying to figure out how I can jumper these to this and make the screen visible. I don't really think that's possible. I guess I could try and take the screen out quickly. Why don't we do that? We'll take the screen out here. Do it, and we'll see what we get. Oh, this actually might be... there's a gasket in here because I believe these are somewhat waterproof. Woof, there we go. Okay. Oh, hopefully that's not... Yeah, it looks like just rubber of some kind. Not like a paper or anything like that. Cork that's going to wear out by removing that. So, positive, hard to see, but there's a positive on there. Gonna make the assumption here that red was positive. Turns out this thing doesn't work after this video. It's probably because of that. Now the good news is we can actually check that because we can just turn the meter on and I should see the reading whip up the way it did earlier. Okay. So let me see if I can just flip this around yet again, so we can... Okay, we can see that. That works. All right, now to try and put some batteries back in this guy. And... Okay, that's off. Dude, Okay, positives go this way. I can slightly see the symbol through the plastic here. We're gonna put the batteries back in this way again here. Ooh, it's not good. The screw's like hanging out of the battery case here. We don't need that guy there. Put these in our pile of screws. Put the final battery in. So the other thing I read, or I learned reading, is that these supplies actually, the high voltage supply is such low power, they actually recommend you use a giga ohm resistor, or at least something greater than 100 mega ohm. And when you're doing that high of impedance, you really need a good multimeter. So I'm just going to turn it on and see what we get. Now I have to do this in a way that I don't get electrocuted. Okay. You guys probably can't hear that. But it's buzzing still. Which leads me to believe then that nothing is functional. So I'm going to grab my oscilloscope here and see. No, maybe I'll first grab the multimeter and see what I can read with this guy. So let's find a ground here. I know. Oh. You know what? I'm trying to decide if this ground not being grounded matters. It might. I'm not even sure where I want to ground this to. Just because I don't know. Right now this case isn't in contact with anything, so... Oh, okay. It looks like the ground connection might actually be made through the edge of this flyback here. Yeah, let's see what happens now. We're not seeing that same type of arcing. That I was before. But I'm also not convinced that... Let's get the check source out. Put it on 1x, I guess. Nothing. Nothing at all. Let's get a meter out. Supposedly measuring the voltage like this will throw off the reading, but I kind of don't care. Overload. Okay, so that's a good sign. Although I think, okay, 1,000 volts. So I'm putting out 570. Although, if this is dropping 300 volts somehow, this might actually be functional as expected. I guess the other thing worth noting is that this meter is going to pull 590. 590. Ooh. I actually see sparks to the unit when I do that. 43 volts. So I think since I have hundreds of volts there, I think the next step then is to get the oscilloscope over here. Another relic, a Philips scope. You know, I bought this scope when I was in high school off of eBay. Probably, 15 years ago. And believe it or not, the thing still works great. The only downside is when I'm doing digital measurements or even power supply work, it'd be really nice to have a scope that you could actively save the trace and do analytics for you, like peak voltages or duty cycle or frequency. that would make life quite a lot easier on occasion. I'm going to set this to 10x just because I don't know what my peak voltages are here. I'm going to go on A trace and center it. My guess is we're going to be, probably going to be in the tens of kilohertz, but I honestly don't know. This is kind of an investigation of an ancient switching power supply. Oh boy. Okay, there we go. We have a signal. Let me get this thing triggering somewhere happy like. So it looks like, probably because of however the flyback is designed, it's actually inverted right now. Trigger on A. There we go. Question becomes, can you guys see? Oh, wow. There is quite a voltage spike there at the end of that duty cycle. Yeah, I think you guys can probably see that. It's hard. I'll boost the brightness all the way, but you can see at the end of the duty cycle, it actually pops at least 500. Yeah, so that's where you're getting the 900 volts from. This down here is like 70, 80, and then... So I actually can't even measure that at its current location. I'm going to try moving the trace down to here. That way we can still see the bottom undershoot. Let me move it way down. Wow, okay, even moving that thing way down, we just can't get that trace even on the screen. Which could also mean that we are producing way higher voltage than we should be. The one warning I also read is that that type of behavior can for sure damage your meter. Alright, since we can't see that anyways, I'm going to recenter line this. We've got 50 volts per division because that's a little bit more interesting. So, the only thing that does worry me is that the counter is completely stopped. It's not full ranging the meter at all anymore, which makes me worry that something became damaged permanently in this guy, which is not fixable. What do we do here, guys? The diode seems to be, let's try measuring a few different points with this. So that's one side of the flyback diode. Here's the positive rail. Supposedly we're dividing by 10x there, which is kind of scary because, oh, there we go. Okay. So here we have 0, we have 5, 6, 7. So it's going between about 7 and 800 according to this. Okay. Fair enough. You guys can just barely see that oscilloscope. So we have 7 to 800 volts on the positive side. Oh, wow. Yeah. Look at how if I just touch this to measure with my meter, it actually drops to almost 200 volts. That's how limited the output of this supply is. So just having my scope on there, I notice now we're only reading 420. So just my scope is dropping it a significant amount of voltage as well. So our power supply is switching at, let's see, milliseconds. That's just gonna count this out here. Again, it'd be nice to have that auto scope, I guess. It looks to be about 2 milliseconds. So that's only, about 500 hertz. The period's about 500 hertz. Quite low, but I guess back in the 50s, maybe that's what you had. So then the other possibility here is it could be actually the Geiger Miller tube could be burnt out. Although I don't know if I really remember this device making a hum before now. But certainly going to the test probe here, we're not getting anything. So I'm going to turn this off for a sec. You know what? No, here, we'll keep, we'll probe a few more things. Okay, so that side's ground. Interestingly, this side is very rounded, but I think that means that guy's working appropriately. All these resistors are... Yeah, for the most part, all of this is... Huh. For the most part, all of this is functioning as expected. So I'm going to turn this off. For those of you that have never taken one of these apart, this is the Geiger Miller tube you can see in here. So I'm going to carefully unscrew it. Carefully pull it out. You can see the window of the tube here. The rest of the tube is probably a steel of some kind. But then there's an open window, and I don't know what material those windows are made out of, if that's glass or just a very fine metal. So the one thing I don't know how to do is test these tubes, unfortunately. But the contacts look okay. I mean, they don't really look corroded or anything like that. So my guess is that this is okay. I'll just try turning it on. Yeah. So again, we're getting nothing from the operational check source. The other thing we could try doing, and I don't know how good of an idea this is, but we could try running it without the Geiger tube in. Hopefully we don't blow up the meter. Well, okay, it's still the same high voltage. But what is interesting there is it actually runs. I'm tempted to get a piece of resistor and try shorting it out and seeing what happens. So I'm going to grab something to hold this with that's insulated, at least to some extent. This is not a large value resistor, but it honestly shouldn't matter. I believe we got to short pins 1 and 2. Not quite large enough. Here we go. 1, 2, 3. Nothing. Okay, how about here? Nothing. Maybe these two. Interestingly, nothing. There we go. And now, this would be kind of considered dangerous, so it looks like we're shorting pin 3 to pin 1. But again, just the fact that putting my meter on the high voltage supply drops it by 100 volts means that there's basically no current that you can suck out of this. So I'm going to put it on the 1x setting, and if we pulse this thing in short circuit... Oh, okay. Oh, man. So that's both good and bad. The good news is I can get my meter to climb doing this. The bad news is that that also then means that it's probably the Geiger Miller tube that's burnt out. And unfortunately, a new tube for one of these is not cheap. Yeah, if you see it, the faster I wiggle it, the higher the counts go up. So, I'm going to turn it off again. We'll try putting this tube back in. But this might be the sad end of my Geiger counter here. Oh. Nope, nothing. Because you should see the high voltage pinning up and down as we get tube shots. And I don't see anything. I can get a more radioactive check source quick, I believe. Here's a uranium marble. Radioactive because it has uranium oxide in it. Actually, kind of the same reason that. So we're going to put on maximum. Not that that depleted uranium check source would really ever go bad. And that is unfortunate. I think we found the root of the problem. I think it's our Geiger Miller tube. Yep, because the voltage seems reasonable. We could try playing with the voltage setting, but I don't know how good of a plan that is. I guess it doesn't hurt to do it now. Screw this guy back on here. You can't really see from the camera angle, but on this board there's the two adjustable pins here. One is the high voltage adjustment, so when it's on we can just tweak this guy and we can watch it go up and down on the scope here. Screwdriver's too small. Wow, that's actually very sensitive. Yeah. Even going to a much higher. Even going to a much higher setting. As you hopefully could see on the scope, there's not a single click that you get. So, I think it's safe to say we're done. I'm going to rule it bad Geiger tube, and I guess I'll go see what I can find on eBay. But, I have a feeling you're not going to find it. You know what would have been helpful? My guess is not all of these have this schematic. Fortunately, there's some rust there, but you guys should be able to see it pretty clear. And save an image if you want to. Oh yeah, so looking at that transformer, is that a flyback? Let's see here. Wow, actually that's a more interesting transformer system than I thought. They actually show two separate ones in here. Interesting. So, that's it. We're going to get a new Geiger tube one of these days, maybe, and see if it takes care of the problem. But until then, guys, thanks for watching, and if you're trying to troubleshoot your own, hopefully now you learned a little bit, and good luck.